please.
That might be like the most epic last name ever.
What?
Rambo.
Paisley Shannon, you've been signed out.
You might want to wait. You can sit through this class, you don't.
All right, so here's what you got to remember with isotopes. What this they are atoms of the same element with different masses. So when we look at this, these are the mass numbers for the isotope. Now I could have you calculate out based off of those. I could get you to give me the number of protons, number of neutrons. We're not going to focus on that. But we want to get the average atomic mass, so in order to do that, we have to take, and it's the summation of all the isotopes times their decimal of the percent abundance. So we can't do this calculation with percents. We have to get rid of the percents, which means move the decimal 2 places to the left.
Oh, we did this.
Did we?
Yeah.
Oh, I wasn't there that day then, dude. Y'all like,
Oh,
Flash my brain.
yeah, I forgot about this.
Then we can fill it all in, so it would be 88 AMUs or grams per mole, however you want to do it, times 0.8256 plus 86 grams per mole times 0.0986 plus 87 grams per mole times 0.0700 plus 84 grams per mole times 0.0056. Throw that all in a calculator and we will get an answer.
Yeah, that's why I said you have to read the question to me. I'm not good with words, I'm just good with numbers.
Don't worry, we will make you good with words in this class.
You can try.
Following isotopes.
Restroom, main restroom.
Percentage abundance.
I have too many. There's not any left.
I would like to teach you around.
Boom.
That's not for.
So you should get 87.6928 grams per mole. Look at astronomers, average atomic mass. 87.62. Pretty close.
Okay. Cool beans.
Nice. Yeah. What's up?
Do you think you could teach somebody that doesn't speak English chemistry?
Did you get 87.2?
No.
Oh god. Cause they'd have like they'd have different words for gram and stuff.
Do they? I don't even.
Gavin Hatfield to the office.
I got 87.222.
Where did these numbers even come from?
Wait, how'd you get
Okay.
88?
So you would just give us those numbers?
Yeah.
Automatic, okay.
222. Oh god, I got 87.222. Look what I got.
Alright.
What you got?
Is that all?
No, it's not. Never mind. Wait a minute. Can we just like tell the office like wait to go to the doctor?
Oh, okay, so it's 20.
0.07.
So, is the point, oh, it's 0.9.
Yeah.
Where'd that 6 come from? So they always have to line up? Always line up?
Yeah.
we never did this.
I
didn't get that either.
Were you in here when we
Wait,
did
so
this?
that's the answer.
Exactly, because we didn't.
6,
No, but I got in here 2 weeks after y'all started.
7.
That's not real.
You didn't do the 84th.
I forgot 84.
Yeah. You don't have an isotope taken into the
So
0.56%.
So whatever the greatest decimal is, they all have to have that amount. So how that's 0.8256, it has to be 0.986.
No, the reason it has to be like that is you gotta move it 2 places to the left. I tell you, you gotta just
Okay,
move it 2
I
places to the
only
left. You're really dividing by 100, is really what's happening.
I moved those only by 1, because I thought you only had to move it.
I got you. Any other questions there on the average atomic mass one? This is good practice for you. Okay. Once you're done with that, I want you to try the mole conversion. Now be careful here because there are 2 things that are being asked of you. I've combined the molecules and determine the volume.
Oh.
You have to have a plan for both.
Oh, but that's not as easy as the other ones were. That's right, because you know what? By golly, I'll put my chem kids up against anybody's.
So we gotta make sure we got you ready to go. Do this. I'm gonna give you 12 minutes. Hey Siri, start a timer for 12 minutes.
Okay, thanks.
So then
All right, so here we go. Here's what I'm going to do because I am noticing some issues and problems. I'm going to try and write some steps down as I go through this too, which is why I have over here. So here are my steps. Step 1,
Microphone.
read.
Uh-oh.
Can't do nothing until you read the problem. Okay. Step 2. I'm changing this compared to how I used to do it because I think I'm seeing with you guys this will be more useful. Step 2, I'm saying, take the number I give you and write it down. 8.95 kilograms CO2. We'll write it.
I think I might have it.
So step 2, write number to start with. Down. And set over 1. Little note to have here, because I'm watching several of you make this mistake, and I keep telling you not to make it. No unit with number 1. So there's no unit down here. There's no unit goes here. We're just setting it over 1. Now, step 3. Make a plan. So in this case, I'm going to look for my plan. So we're going to make 1 in blue. So I have plan A.
Why in the world do you have plan A, Mr. Hall? That makes no sense. Why is there a plan A? Well, I read the question and I see how many molecules, so 1, I'm being asked for how many molecules. But then I say determine the volume of the sample. That's 2 things I'm having to find. So the first one is plan A. I'm going to look at finding molecules. So we got to have a start point, and we have N. So where am I where am I starting at? I've been given kilograms, so that's mass. Then I want to end at molecules. Can I go straight mass to molecule? No, I can't do that. I have to go mass to mole, then to molecules. I can do that. So that's plan A. But that's only for one answer. Now I need plan B.
Plan B will be for volume. I'm starting at mass. I want to end at volume. Can you go straight from mass to volume? No. Check something out. What do you got to do? You got to go from mass to mole, from mole to volume. Why did I draw it like this? I drew it like this so you can visually see something I'm going to do. They both have this in common. That makes it to where both will be. You guys can do this. Some of y'all were wanting to go mass to mole to molecules. Then you want to go from molecules to mole to volume. You absolutely can do that. That's a little bit more work than I'm willing to put in. I would do it for you though. I love you dearly. So I'm going to go from mass to mole. Then I'm going to set up two different ones. I'm going to take this number from here and go to molecules and go to volume. But you have to watch something. If there's one thing you're going to learn, Mr. Hall is mean. He is so mean to you. Mr. Hall did not set you up for success on this problem. Mr. Hall set you up for a, ha-ha, I got you. Kilograms. When it comes to mass, off the periodic table, what is the units?
Grams.
So, grams is what we must be in. It cannot be grams per, it cannot be kilograms because it has to be grams because it's grams per mole. So, we can't do that. This is not an option. You have to notice something, and things build in this class. Okay? This is why it's important we get it from, and we start building upon it. So you got to get it and know it. We did metric conversions. We have to go kilogram to gram first. You should be able to do this. If you need to set it up, set it up. So 8.95 kilograms is equal to how many grams? Follow your steps. Step 1, write the number down. 8.95 times 10 is something or another. Step 2, find what is the same. What's the same?
Grams.
Little g, little g. Now we find the difference in the exponential values of the prefixes. I have k here for kilo. What's the exponent value for kilo?
3.
Minus the exponent value for, oh, there's no prefix there. What's that?
0.
0, because it's a base unit. 3 minus 0 is 3. Very good. So 8.95 times 10 to the third grams. Take that number and set it over 1. So 8.95 times 10 third grams of carbon dioxide. Set that bad boy over 1. Now, we're ready to execute our plan. So, plan A and plan B both say we go from mass to mole. So we do that. We must have a conversion factor, yes? Okay, so here's what we do. On this one, step 4. Convert mass to mole. Hey, here's a hint for you. Mass. Dog. What's something else I'm going to need?
Periodic table.
A periodic table. Okay? So periodic table needed. You got me? So now we set this up. We're going to convert from the mass to mole. What do we got to do? You see this unit? That's where I'm at. I'm leaving it. Yes? We take that and go here. Where am I going goes on the top, and that is
Mole.
1 mole. So we got to figure out the number that goes there with the grams of carbon dioxide. What's that thing called again?
Atomic mass, Avogadro's number, whatever. it is.
When is Avogadro's number used?
When you're
You go
bleeding
into this one.
That's mole.
Atoms, particles, molecules, formula units. That's when Avogadro's number is being used. Question you, am I dealing with atoms, particles, molecules, or formula units right now?
No.
No. I don't need Avogadro's number. What was that thing you said I needed again?
Periodic
You
table.
already got a table.
This.
It's CO2.
Average atomic mass. So we're going to use the average atomic mass off the periodic table to calculate the molar mass, also known as molecular mass. So we set this bad boy up, okay? So to do this, we got 4.1, step 4.2. Calculate molar mass. Yes? We got to calculate that. So in order to calculate molar mass, we write down how many we have. So I have CO2. So I have carbon and I have oxygen. How many carbons do I have? 1. You see this here? Nothing there? That's a 1. How many oxygen?
2.
2 right there. Now, I understand why some of you wanted to take that 2 and distribute in, but you only distribute it in when there's parentheses around it. There's no parentheses here, that 2 does not distribute inward. Now we multiply this by the average atomic mass off our periodic table. So look at carbon. What is the average atomic mass?
12.01.
I'm so proud of you. 12.01. You could have done a little better though, but that's okay. You could have given me some units, but I'll do. What's the average atomic mass for oxygen?
16.20. Grams per mole.
Ah! There we go. Somebody learned something today. Grams per mole. So we get 12.01 grams per mole, and then we get 32.00 grams per mole. Now you add these bad boys together.
44.01 grams per mole.
Ah! 44.01 grams per mole. Very good. Hey, wait a minute. Remind me again. What was I doing that for? That was a lot of math. What am I doing with it?
You put that on the bottom part. Right there. You just put it right there.
The bottom part.
Beside that unit.
Yeah.
I don't know what's that.
It's called right there. Hey, does it matter that you know what that's called? No. Just matters you know where to put it. Okay? So the number is called the molar mass. That's the denominator of our conversion factor. Hey, I have grams of carbon dioxide canceled, right? Don't talk about it. I'm left with moles of carbon dioxide. Where's the middle point in the plan again? Mole. I will stop here and do this calculation. So I will literally punch this in a calculator because I don't want to do a ton more work. You can if you want to. It's all up to you, I mean. So divide that by the 44.01. Mr. Hall get 203.3629. Yes. Mole carbon dioxide.
Could we just round it up to that 363?
That's what I was
Yeah, if you did .363, that's fine. I'm not gonna kill you on that. Now, I want a couple places past this. Don't go crazy. All right, now we have that number. That's the mole. So now what I can do, I can execute the end of plan A and the end of plan B. So this is what I'm saying. This will be the finished product for plan A. Plan A, I take this number, 203. Well, I need to do it in black. Hang on. I want you to see the numbers. I try to make the colors match. 203.3629 mole of carbon dioxide. Set over 1. You know what the funny thing is? Guess what Plan B is gonna look like? It's the same thing. So we set it up. 203.3629 mole. Carbon dioxide, set that over 1. This right here is why I stopped here and I threw that in the calculator. Some of you went ahead and did one big huge thing, got molecules, then you took molecules and went to volume. That's fine, you will get the same answer. But what am I looking to do? I'm looking to do less work. So we gotta set this thing up. What was Plan A looking for? I'm going to where?
Molecules.
So what unit and number is on the top?
Avogadro's
Avogadro's number. Molecules. CO2. Then I have mole, carbon dioxide on the bottom. Plan B takes me where? So if I look, what number and units on top? 22.4 liters is on the top. 1 mole. Mole is where I'm leaving, so mole is on the bottom. So, throw it in the calculator. We'll store that alpha A, 6.022, and I get 1.225 times 10 to the 26th, and that is molecules. CO2. Sorry, Mr. Hall, running out of space. My backpack's probably way there. I'm just kidding, that's hands. And then I have alpha A times 22.4. I get 4,555.328, and that is liters of carbon dioxide. Mic drop.
Is that 4,555?
Oh yeah. 4,555.328. Questions?
I don't think I did it right. Well, I did the one where I did them all together, and I got 2.5034 or 35.
Let me see your calculator.
Like I did my whole thing there. I didn't choose a block.
Okay, that's cool. Oh, that's your problem there. You divided. You shouldn't divide it. You got separate them out. You combined it all together. So, first thing is right, like right here.
I need Braxton Gullett and Donnie Walker in the office. Braxton Gullett and Donnie Walker in the office, please.
Not divide.
Oh.
Then you should also break here after that,
Yeah.
because you have you dividing by Avogadro's number.
No, just,
At least that would just cancel Avogadro's number out.
so it's just for the.
And then you are dividing, sorry.
How is that?
You're dividing by the 22.4, you should multiply by 22.4. So do this one first. So there, that gives you molecules. Then go back, you will take that number, divide by 0.22 times 10 to the 23rd, and then multiply by 22.4. Yeah. How are you feeling?
Very good.
Hey, can I tell you something?
No.
Guess what you just did?
The band.
You just did a pop off.
I feel like I almost had.
Now leave that